EMG question of the day. Which of these waveforms is more likely to be abnormal? Please take a look at these figures and choose A or B. The most common mistake interpreting EMG are calling Satan Santa and calling Santa Satan. False positive errors are probably more common and worse than false negative errors. Both types of errors, false negative and false positive, are often related to a mistaken binary decision based on overemphasizing or underemphasizing similarities and differences shared by normal and abnormal EMG findings. So let's first look at similarities in the figures presented in this question. The lower tracing of the first panel and the lower tracing of the second panel are rather similar. Each is characterized by a biphasic spike configuration with a negative onset, each being the expression of muscle fiber action potential and each being recorded by an electrode close to the muscle fiber, right above the site of the action potential initiation. In these cases, the electrode initially captures the sync of a symmetrical quadrupole, followed by the recording of the source of two asymmetrical quadrupoles moving away, thus resulting in a biphasic spike with a negative onset, as you see here. Summarizing the similarities, we can say that both are muscle fiber action potentials and both are being recorded with the electrode tip just above the generator. So now that we have looked at the similarities, let's look at the differences. The differences are obvious. Compare the upper tracing in the first panel and the upper tracing in the second panel. The differences relate to rate and rhythm. The rate in the first panel is 16 Hz, in the second panel 8 Hz. The activity in the first panel has an irregular rhythm and a regular rhythm in the second panel. So let's ask ourselves two questions. One is almost the same as the original question, which we will address at the end. Which of these activities could indicate pathology? And the second question, which we will address now. Could these activities occur at the same segment of a muscle fiber under different circumstances? Let's see. This drawing is the same one you saw in the last question. It represents normal muscle fibers and neuromuscular junctions. On day 0, a needle in the end plate zone will record end plate noise and trigger and record muscle end plate spikes. As we mentioned when talking about the differences between the two upper panels, they occur at a relatively fast rate of 16 Hz and the rhythm is irregular. The amplitude, as you can see here and here, varies. The reason for this variation is not clear and we will not dwell on it at this junction. Let's now go from day 0 to day 1. As you can see, the neural component of the neuromuscular junction has been teared from the muscular component. At the muscular component of the neuromuscular junction, the end plate, we will find acetylcholine receptors, wild-type voltage-gated sodium channels, and wild-type voltage-gated potassium channels. So now that we have looked at day 1, let's look at day 2. And again, let's look at the end plate zone. As you can see, channel-wise, not much has changed. An EMG will show no end plate noise or end plate spikes because acetylcholine receptors are not being excited and those wild type voltage gated channels are not being activated. So we looked at day 2. Now let's look at day 5. On day 5, the end plate are empty of functional channels. Acetylcholine channels are disintegrated and wild type voltage gated channels are gone. An EMG will again show no activity. There is nothing to excite or activate. So that is on day 5. On day 7, the end plates are gone and the channels in that area have also undergone significant changes. The acetylcholine channel are gone and a new type of channels have appeared. The non-wild type voltage gated sodium and potassium channels. These non-wild type voltage gated channels have substituted the wild type voltage gated channels that were present not only in the zone of the now gone end plate but also in the rest of the once normal muscle fiber. An EMG done in the end plate region as well as in any other region of the muscle fiber will show discharges with slow rate of 8 Hz and a regular rhythm. These are fibrillations. These fibrillations are generated by the opening of non-wild type voltage gated sodium channels governed by the non-wild type voltage gated potassium channels acting as pacemakers. So the answer to this question is B. Thank you very much for your attention.